Hey, Walter Sorrells back with more tips for the knife maker. Today, making an arm for a Bader belt grinder. So I have a bad habit of buying stuff, sort of setting it up a certain way, and then just leaving it there forever without any modifications. I bought a Bader BIII belt grinder, gosh, almost 20 years ago now, and I've done almost nothing to modify it over the years other than to fix occasional problems that have cropped up. Now, the way that the Bader works is that you have arms with attachments on the end of them. Those attachments could be contact wheels or platens or whatever. And so the arm and the attachment are separate. So I bought some attachments that I didn't have arms for, and we'll see how this works. So for years I've been taking them on and off the arms instead of having arms to put them on. It's easier to change arms than it is to change attachments. So anyway, I could probably go to Bader and buy new arms for, nothing. But I just felt like doing it myself. So today we're going to make an arm and we'll show you how the attachments fit onto it. Before we go any further, let's see how the Bader works. All of the attachments you can buy, contact wheels, platens, slack belts, setups, whatever, they all attach to an arm using this little mating system. Now you can either take the arm on and off, or you can put the attachments onto the arm and leave the arm on the machine. It's a lot easier to take the arm off rather than to take the attachments off. But here's how the attachment part works. You've got a little roll pin and then a round boss or projection here that mate with all the attachments. Then a hex head cap screw tightens the attachment down so it doesn't walk off the arm due to vibration during use. What makes the adjustment part work is that there's a saw cut running diagonally into the bore of this mounting hole. That gives just enough clearance so that you can snug down the screw and tighten up the arm. Very simple. Now if you want, you can buy one arm and umpteen attachments, but as I said, it's a lot easier to take the arm off than it is to find an Allen key, unscrew it, remove the attachment, reattach, tighten, change the belts, blah blah blah. So ideally you have an arm for each attachment. But when I bought this machine years and years ago, I was on a little bit of a budget, so I cheaped out on buying that arm for this dinky little contact wheel, which in fairness to myself, back then I hardly ever used. Now, however, I use them all the time, so I've been way overdue to buy an arm for this little attachment. Now, just for yucks, I figured I'd fabricate my own. In no way does this pass the ROI test. I just did it for fun. Mostly I did it on my CNC machine. You could do this whole thing with a hacksaw, a file, drill press, maybe a belt grinder. It would work just fine. This just happens to be the way that I did it. So first I designed the part in Fusion 360. Maybe I'll show that in another video, but it's really just a bone simple design. Anybody who's used CAD/CAM programs at all could do that in their sleep. So before cutting metal, of course, I had to measure all the little bits and pieces to work out the exact dimensions. Incidentally, if you are interested in doing this at home, I've put my plans on my Patreon page. You can hit the card in the corner to support the channel and score plans for this and lots of other stuff I make by being a supporter on Patreon. We only have one piece of material required for this job. It's a piece of 1 1/4 by 1 1/4 mild steel bar. Not square tube, it's solid steel. We want this nice and rigid. So I'll chop it off to 18 inches. Anyway, the basic idea here is that I started by drilling the holes for the 1024 screw used to tighten the fixture. First comes a 1/4 inch clearance hole that runs about 1/2 inch deep. It's just wide enough to allow the 1/4 screw to rotate freely in the section that goes down to that little saw cut that we'll be putting in later. Next, I drill a through hole using a number size drill that works out to 201 thousandths. That hole is then tapped. Later, I'll saw out that slot we showed earlier. So what happens is that the threads of the screw engage with the threaded part of the hole, but not with the wider clearance hole at the top. turn the screw, and the top section snugs down. Now I'll rotate the bar 90 degrees, indicate the part again with my Heimer, and then run through the ops for this section. First, I'll mill out the pocket, or the flat here. I mill a lot of really hard tool steel and a lot of very soft handle material on this machine, but I almost never mill mild steel. So, while I'm doing this, I'm testing out some feeds and speeds for future reference. This is an Al-tin coated carbide mill, so it's intended to be run dry and fast and hot. But just for yucks, I tried using some coolant and some lubrication to see what it did. As expected, didn't do anything useful at all. The theory is that using coolant on titanium aluminum nitride coated carbide is that it's actually bad for tool life, as it causes rapid fluctuations in temperature that make the carbide unhappy. While we were making this cut, I increased and decreased the feeds and speeds just out of curiosity to see what was kind of the sweet spot for this particular cut. Once I'd milled out this flat, I drilled the hole for the roll pin and a starter hole for the other hole. Then on to a 3/8 inch titanium aluminum nitride coated 4-flute carbide end mill to bore out the larger hole. I bored it at 752 thou, just enough to give it a slip fit for the 3/4 inch boss on the attachments. Now for the final part, the little diagonal saw cut. I did this on my water jet machine. Yeah, no, I don't have a water jet. So I used this high-tech device here, a hacksaw. The hacksaw worked exactly to spec. I know this for sure because, as you can see from the professional bandage job on my hand, I conducted a preliminary test on my finger. Nice and sharp. Alright, let's test her out. Everything fits perfectly. Now I'll snug it down. Now the ultimate test. Here I'm polishing up the finger slot on one of my Tactics Armory operators. At this point, this knife's about 90% complete. Everything's running smoothly. Once I've got everything tightened up, it tracks really well, works like a charm. After knocking a few chamfers onto the sharp edges, I'll throw on a little paint, and here's the final product. So I hope you got something out of this, even if you're not a CNC guy. Kind of one of the points that I always like to make is that the best tool is the one that you have. In this case, CNC was the way to fly on this, but could have done it a lot of different ways. Could have done this on a drill press, could have used saws, could have used belt grinders to grind some of these surfaces in. A lot of ways this could have been done. This just happens to be the one that I chose for this particular build. Thanks for watching, guys. If you feel like you got something out of this video, don't forget to subscribe. Also, click on the link to Patreon for a great way to give back to the channel. Plus, check me out on Instagram, Facebook, Twitter. Links in the description. If you want something sharp and pointy, maybe a gift for yourself or one of the cooler people in your life, check out my Tactics Armory website and pick up one of our tactical or outdoor knives. And finally, if you want to learn to make Hamones or Japanese swords, check out WalterSorrellsBlades.com, where you can find videos about how I make Hamones, as well as forging, mounting, polishing, and fittings for Japanese swords. Thanks, and see you soon.